Welcome. The first lecture is related to Introduction to Distributed System. So some of the basic known definitions from the standard books of distributed system are a system in which hardware or software component located at networked computer communicate and coordinate their actions only by message passing. The key point here is there is a network of computers which are able to communicate and coordinate only via message passing, which is the important point over here. Fine. And the second definition from the Tannenbaum, a distributed system is a collection of independent computers. By independent computers, we mean that the computer can work separately, independent of each other, but they are working together for the time being as a part of distributed system. So a distributed system is a collection of independent computer that appears from the user perspective of the system as a single computer. So user doesn't know that whether multiple computers are working for him or she is getting a service via a single computer. To the generations of distributed system. Actually, what you will see in the points like scale, heterogeneity, openness, and quality of service, that the concept began on a very small scale with very limited resources, and as on we are growing in terms of technology, advancement, and research, we are able to develop a wider and much more efficient distributed system. The selected application domains and associated network application of a distributed system. So here what I want you to do is to pause the video and look at these key domains and the applications which are associated on the network. And these are basically what you will find are examples of distributed system. So kindly pause the video and watch and then resume the video. Come to a basic example of distributed system, a field basically cloud computing. You must have heard the name, but what actually it is? There are multiple clients which don't actually have their own hardware or software support or some application which they are trying to use via third party vendor. So what actually they do? They are connected to the application servers or storage servers or computational service, whatever you can say, via a medium which is internet. And the cloud support system, they basically provide three platforms like infrastructure as a service, platform as a service, and software as a service. So whichever mode of service you choose, they are giving it to you, and it appears to you like you have a dedicated system for your services, but which actually is not the case, and the service supplied to you is via a distributed system. Features of a distributed system. The features of a distributed system, first is the transparency. Transparency basically means hiding the details from the user, and we'll talk about transparency in detail in the coming next slide. The second point is user mobility. The distributed system should not restrict a user to a particular node, and it can allow the user to go from one node to another node, basically a one system to another system, and can still do his work as if the actual work was on the later system on which he is working on. The third point is performance. Basically, performance comes from the fact that a distributed system require a network access time, but the network access time should be managed in a manner that it does not considerably downfall the performance of a distributed system. Fourth point is simplicity and ease of use. So simplicity and ease of use means that the user can handle this distributed system in a simple manner, and the commands or the file system which he is using should be simple yet efficient and able to handle the problem of the user. The fifth point is scalability. While talking about the scalability, the point scalability here refer to adding new nodes in the distributed system. So adding new nodes in the distributed system should not affect the performance of the distributed system, and it should work in a manner in which the distributed system is actually working in the previous before adding the new nodes. Sixth point is high availability. The high availability here refers to the system being able to handle the failures and able to accomplish the required job. So if a node fails, that doesn't mean the system is not in the state to cope up with the user requirement and should be able to fulfill whatever the requirement of the user are. Our seventh point is high reliability. High reliability means that the user at any instant of time should not suffer from a data loss being on a distributed system, which may be possible because of some node failure or some any other issue. But the reliability here means that the data should not be lost in any manner and the system should maintain its state. Data integrity. Well, talking about distributed system, the replicated copies of the data are kept and the integrity constraints are ensured in a manner that the system state is consistent all the time. Ninth point is security. The system, our distributed system basically should ensure the privacy or the controls which are assured to the user, and his data should be secured in a manner that nobody else other than the intended user can extend or extract the data from of a other user. Our 10th point is heterogeneity. Heterogeneity means that the distributed system does not have a limitation that all the systems should have a same configuration which are connected on a network. They can be separate systems with different configurations. So it is not an issue that all the systems should be of similar or exactly same specifications. As I talked to you in the previous slide that the transparency will be discussed in the coming slide. So as I told you, the transparency refers to hiding information from the user. So access transparency. Access transparency here means that the user should not be able to get the information whether he is accessing the resources from the local system or from a remote system. Okay, fine. The location transparency. The location transparency refers to the hiding the network location of the system providing the resources to the user. Concurrency transparency. Concurrency transparency enables several processes to operate concurrently without having the interference between each other. Replication transparency. Replication transparency ensures multiple instances of resource to be used for increasing the reliability and performance. Failure transparency. Actually, in a distributed system, failure do happen, but the program should complete despite failures of hardware or software components. So, user should not get the information whether while running a process he may have faced a failure or not. Mobility transparency. Mobility transparency, it ensures that the user doesn't have information whether the movement of resources and clients within a system might have happened or not and should not affect the operations of the basic program or the user. Performance transparency. It allows the system to be reconfigured to improve the performance without the prior knowledge or after knowledge of the user. And scaling transparency, it allows to expand the scale of the number of systems without the knowledge of the user. In case of any queries, you can mail your queries at utsav, that is utsav @gweca.ac.in. And as a part of your first assignment, you need to go through the slide in which we have studied the application domains and associated network application, and you can select any application domain with an associated network application, and you need to prepare a brief study report related to it, that how actually the thing works. Thank you.